Mario with MIA Microflight. Today is Thursday, January the 29th, 2026. And I am going to be doing this video talking about the... just got to clean a little bit here. Talking about this helicopter. Once again, I did a couple videos yesterday, actually a few videos. And I got this helicopter to fly so sweet. It was flying perfect, hands free for it remained there, throughout the whole video, basically. Just amazing flight. At night, I decided to do another flight after I had charged my battery. I had relaxed a little bit. I decided, well, let me try to get another flight at night. It did it again. No way. This thing started creeping up. I had to cut down the throttle. Luckily, I was able to catch it with my other hand. It dropped dead. I started to see if I can get it back into a proper setting. I didn't have that luck. So it totally got out of whack. I don't know what happened because I didn't touch the helicopter. It was just sitting after those beautiful flights. And not doing anything. I would understand if the controller had gone out of calibration, if it it encountered a hard landing or something like that. But no, it was just fine. So it just went out of calibration again. That to the point that I was testing it, just kind of holding it lightly and see if the rotor, when you give throttle control, a little bit of throttle control, if it remains kind of at a certain height. No, this thing, it had full power. It wanted to take off, and there's no way that I would risk flying it again that way. So I decided to look into the electronics. I did a full video on that. I hope people are watching my videos because the number of views that I'm getting on my videos, I think my videos are being blocked for some reason for the algorithm, or I don't know. I have a suspicion that these things it's more than the algorithm. So it's I did those videos. I would urge you to look at all my videos, the good ones, as well as the ones where I discuss some of these things that I've been doing, and some of the not bad ones, but the ones that I discussed the cons of this flight controller. So what I did last night, I was up very late. I just got up to have breakfast. Is I completely removed this little part right here. Let me focus in on that. But before we do this, let me do it this way. So I removed the receiver. The receiver is the flight controller. It's an integrated receiver and flight controller, and in addition, it's got this barometer. I removed this, but I couldn't remove this cleanly, and I ended up ruining some of the traces here. There's no way to remove this cleanly unless you have proper tools. So I mean, at this point, I didn't care because I was thinking, if I can remove this and maybe have access to the ESCs and use the ESCs as standalone, I can put my own receiver and stabilizer and fly this as a regular helicopter, so that I have full control on the throttle. Because this right here, the programming in this flight controller that needs this barometer, you can't fly this without the barometer. I removed this, hoping that I could fly it just as a regular radio. Just a regular RC helicopter with of course without the stabilization on the servos, on the cyclic servos. It doesn't work. It needs this barometer in order for the flight controller's software. It must be programmed to read these things, because this is communicating constantly with the flight controller, and upon startup, upon binding, and all those steps, this is required. So I basically just ruined this control. This still works with that, but it doesn't bind. It doesn't it doesn't turn on, and nothing happens. But this does come on. I mean, the receiver does work, but it's just not going to turn on it's not going to bind it. It's not going to turn on the motors because it needs this barometer sensor here. Now the sensor is, let me zoom in on this here. That's the barometer sensor right there underneath this this foamy frame right here, and that is the strip that that is soldered to the receiver. Okay, and for anybody that has done a do-it-yourself gyro with those MPU 6050 gyro accelerometer boards, I have done several of those that I use on my regular helicopters, and they work just fine with a little massaging of the code. Just to get it nice and smooth. I've done that, so I'm very familiar with the ins and outs of the inputs and outputs of these devices. And so this has the same thing. It's got it's marked right here, VDD, which is the supply voltage. It's got SCL, which is the clock. SDA is the data, to transfer data back and forth, to communicate with the receiver flight controller. And it's got ground, of course, and an interrupt. So those are the pins on this flight controller receiver. And this barometer sensor is no different than the MPU 6050, which is also a gyro accelerometer device. However, because these things are made from different manufacturers, and the coating is different from one to the other one. You can't just replace this with those MPU 6050s. This one is different, and also this receiver. I think that this is an SMT32 type microprocessor that I believe is used on these receivers versus an Arduino, say an Arduino or an AT-Tiny85, for those that understand electronics, are familiar with that. So basically, I when I removed this, and I kind of had a suspicion that this wasn't going to work without this thing right here, but I decided to remove it also because in my other video I noticed that this had a hairline fracture on this end right here. It looks like it was bent, creased. These flexible PC boards, they're very susceptible to creasing and developing hairline fractures because they're so fragile. So this one has a hairline fracture right there, and I believe that was the issue, but I think it's an issue with the flight controller itself. After looking at that little hairline fracture, I decided to if I'm going to remove this, just remove it from the board completely. So that's the reason why I removed this. In that process, I also decided to see if I can trace some of these pinouts. You almost have to reverse engineer these things because there's no information out there that gives you that information. So, but common sense logic. This says battery minus, battery plus, and all these 1, 2, 3, 4. There are 6 pins here. All these 4 pins are B plus, and these 2 right here are B minus, which would be ground. This other side right here, if you look at the board, underneath the board, it says M and M at the ends here. Motor and motor. If you look at this connector right here, the very first connector, that is in continuity with the second pin on this side right here, and that is on the side of the main motor. These larger chips, MOSFETs, are for the main motor, and these smaller chips are for the tail motor. There's three MOSFETs on top, 3 MOSFETs on the bottom of this board. Same thing here, 3 MOSFETs on the top, 3 MOSFETs on the bottom that form the speed control for these motors here. I actually removed the screws here because I was thinking if I can put this on maybe the barometer needs a little bit of a little more cushion and not so rigidly mounted via these screws. So I put this foamy, not foamy, but this clear double-sided rubbery tape here. You can see the underside 3 MOSFETs. I mean, it's very similar to your regular speed controls. However, what the interesting part is that this company is using, because they're using proprietary coding in I think chips also. It's not like a regular speed control that you can just simply find the signal and plug it in, inject a signal there to operate the ESCs. At least I have not found a way to do that. And I've gone through every single point here, just trying to find where I can inject the signal using this servo tester. You can do that certainly with just a regular speed control. Just take the signal lead and ground. And if you connect the signal, which is my blue right here, signal, I am using a separate little battery here to power this, so that I don't need to power that directly from this guy here. So this is powered, and this is providing pulse width modulation via the signal wire and ground. So I connected this to ground. Like I said, these four right here are connected to the B plus, and they tell you right here B plus. And if you put a continuity meter right here, you can see that these are all shorted together. Especially when, well, the two of them are shorted with the switch being on the off side. When this is on the on side, all four of these are powered, except these two, which are battery minus, which is ground. This, on the other hand, is 2 and 2 for the motor, 2 for the smaller motor, are via these pins right here. The center ones, I don't think they're connected to anything. They're not grounded. They're not pluses. I didn't find any connections to anything here. Just using continuity checks. But these two right here, I was thinking maybe they're injecting the signal, right there from this board right here. It's sending, but because this is also communicating with this, it's doing some kind of a handshake there in order to establish the binding and the arming. So I think they're using some special maybe a coating between this board and that board via these pins right here. So it's not a direct, like a regular speed control. That you can inject a signal, at that point right there. I tried tracing where I can inject the signal, because this is basically just like a regular brushless speed control, the MOSFETs, and of course it uses some kind of a processor. All these things work with processors, microprocessors. So this one has its own microprocessor, and this one also has its own microprocessor. Plus, I think they also do because this is also the power distribution board that it is also distributing voltage to this board, but this B plus is not 5 volts. This B plus is the battery. That's why they tell you battery plus, battery minus, which is the full 8.4 volts of a 2-cell LiPo. So what is doing the conversion, the DC to DC converting from high voltage, which would be 2-cell LiPo battery voltage, to 5 volts, which is clearly marked right there, 5 volts and ground, which distributes to the servos, 5 volts and ground, and then the signal that comes from this board right here. That has to be done through a DC to DC converter, and you can see here this is a coil here that is typical of a buck converter, DC to DC converter. So this is doing this, along with some chip on the bottom here, is doing the conversion from 2-cell operation at 8.4 volts to 5 volts to distribute to the servos here. So this is actually the one that has that conversion, and not this board right here, because this board is strictly ESC. However, I have not found the signal point where I can inject just a signal and repurpose this. It would be great that if I didn't have to remove these wires and keep these things right here and just find the signal points. I'm going to still work a little bit on this and see if I can find it. If you are viewing this and you are perhaps a little more savvy with this than I am, I just opened this up and I'm kind of trying to reverse engineer this. as I've done, with a Cork SRB controller that I repaired, and I actually ended up not using that because that's a 72 megahertz flight controller. If you have gone this route, if you're watching this video, please put it in the comments. Help me out here, help others, have that information through my video and through your comments perhaps. That's the reason also why I'm doing all these videos, and I'm putting the emphasis to explain all these things in detail so that others have that information. It's not fun to fly these things without the reassurance that you're going to have consistent flights from one day to another, or from 1 hour to the other. So I would love to see without having to go into a different flight controller. I believe that we can do this. I mean, I've done this stuff before. I mean, for me, this thing is not new in terms of how to control a helicopter, with just standard components. So the way I would do this without relying on this board, like I said, I'm hoping that I can reuse this, and if I can't, well, I can't reuse it. I did read some of the information. When you go on Google and you type, can I repurpose this board, as a standalone flight controller? The AI generator tells you that you can't, because this is not a regular ESC, and because it says that Sierra is using proprietary coding and mechanisms, to make this into a toy grade device, and it's not a hobby grade setup. I mean, this is hobby grade. It's not really, well, it is toyish, but in the sense that you don't have precise control, but it is using MOSFETs, and it's using the same components that you use that are used on regular brushless speed controls. So it's just a matter of finding where that signal point is at, and if I can locate that, I can certainly inject a signal there and use just a regular receiver to send the throttle control signal to that for the main motor, and over here somewhere for the tail rotor, and then just using some kind of a mixing setting on the transmitter. If you have a really nice transmitter, such as the Radio Master or something like that, even my orange Hobby King transmitters do that, have mixing. You can mix that, and that's how I fly my other helicopters without resorting to sophisticated flight controllers and barometers and none of that stuff. That's the other reason why I also like helicopters with a flybar. I've said that in many videos, and I may very well establish some kind of a mechanism here on this rotor to fly this just standard without having to rely on gyroscopes, to stabilize the rotor, flybarless rotors. It's been done in the past. People used to fly all the time, the regular flybarless helicopters, maybe not 5-bladed, but 2-bladed helicopters with weighted blades. And basically that establishes, the gyroscope feature mechanically on the rotor to stabilize the rotor. And yes, it's a little more challenging to hold cyclic control in position, but at least your helicopter is not going to get away from you. So, or it's not going to do some funky things, in that process, as these controllers tend to do. So that's where I'm at right now, and I just wanted to once again get this video out there. Please help me share these videos with other people. Put them in, I don't know, some of your helicopter groups. If you belong to a group, I don't belong to any groups. I stopped joining groups a long time ago because it was more trouble for me I used to post on a daily basis, very similar to what I do with my videos on YouTube. I used to do that in some of the RC forums early on in the early 2000s when I was doing my own helicopters. Creating my own and showing people, and this is before any helicopters were on the market. I started that way before that. AOL, if you're that old enough, to remember AOL, some of the early forums, that's how I started. And then I decided not to join any more groups back around 2003. 2000, yeah, I started leaving those groups and not doing it, not spending time because it was eating a lot of my time doing that, and I moved on to other things. But I've come back full circle, as I said in some other videos, to helicopters because that's been my thing. That is what got MIA Microflights television. That is what put us in on the map of radio control. So help me pass this video on to others. If not so much for for show and tell, but for just as an informative video, and maybe others can chime in and put their own 2 cents, because I have gone online and try to find this information that I'm giving in my videos, and I just have not found to the level of detail, at least, that I show in my videos. And I'm surprised that my videos are not getting the view that I think they deserve, with all this information that I've been sharing and placing on my videos. I seven views, 10 views on my regular long videos is pathetic. I have to believe that that there's some feature there, or some mechanism of some God is watching over my videos and not letting that through. Because I find that hard to believe. I'm pretty sure that other people are that have had the same issues are probably trying to find this information and would benefit from this. And if you have more information that you can share with along these lines that I'm discussing, put it in the comments below, please. Thank you so much, Mario, once again. Stay tuned for more.